Less than 10 months ago, tragedy here at Cape Kennedy rocked this nation's space program, set back our moon landing schedule by as much as a year, and set loose doubts about sending men into space at all. Today, the nation rejoices. Hopes rise again that John Kennedy's goal of putting an American on the moon by 1970 will be realized.
This is the big shot, the ride without astronauts of the giant Saturn V rocket. Project Apollo. This is Apollo 4, the test of our moon rocket in flight for the first time. It is the beginning, the first of many steps which will someday put men on the surface of the moon.
Here at the Kennedy Space Center, the count now is 5 minutes and 29 seconds to the launch of Saturn V, the biggest rocket man has ever built. A critical test of this rocket complex, which is to take an American to the moon. We have two major objectives this morning: to test all three stages of Saturn V. They have never flown together before. The first stage has never flown before. The second stage has never flown before. The third stage has flown before but has never been reignited in flight, as it will have to be on this mission if it is successful. The Apollo spacecraft, as prepared for this flight, has not been flown before. It is a complete spacecraft, except there are no men in it. Three little black boxes doing their work as nearly as they can. And it is to test the heat shield for a lunar re-entry speed of 25,000 miles an hour when it plunges back to Earth some 8 3/4 hours from now. Meanwhile, the Apollo spacecraft will go twice around the Earth and then be fired out into a translunar trajectory, going some 11,000 miles out into space before turning around and then plunging back to Earth at that fierce speed of 25,000 miles an hour, creating a heat of 4,500 degrees on the heat shield. We've never had that sort of a test in space before. Our orbital flights have come back at 17,500 miles an hour with just about half the heat that will be created by this lunar re-entry. That landing will be some 620 miles northwest of Hawaii, 8 3/4 hours after the launch of this, which has been called frequently Operation Big Shot. We'll be tuning in every once in a while now as we get into the last 4 minutes of this countdown to Jack King, the voice of Apollo Control, who we will hear also on the launch. Reminding you again that ignition takes place some 9 seconds before the blast off from the pad itself.
Apollo Saturn Launch Control. We're minus 3 minutes, 30 seconds and counting. The countdown still in process at this time. We've had an excellent countdown since the count was picked up some 49 hours ago. Coming up in about 10 seconds, we'll go on an automatic sequence. The automatic sequence comes in at 3 minutes and 10 seconds, and our countdown is completely automatic from then on down. The automatic sequencer is in. We are now completely automatic. Here in the Launch Control Center, we'll be monitoring some 300 readouts as the countdown continues to click down under the direction of the two ground computers, one here in the Launch Control Center, the other one right beneath the launch vehicle at the pad, but with the crew here directing the operation of these computers. We're now coming down on 2 minutes and 40 seconds and counting. We'll get the sequence start of engine ignition at 8.9 seconds in the countdown, and as the thrust builds up on the 5 engines of the first stage, we should reach 90% thrust and release at 0 in the countdown.
That's a beautiful picture you see from the top of the
20 seconds and counting.
Top of the umbilical tower every once in a while that we pick up. It's one of the 60 pictures fed into the Launch Control Center from the pad that these cameras to operate right through the launch, or as long as they can withstand the searing heat of the blast-off.
This is Apollo Saturn Launch Control, T-minus 2 minutes and counting. T-minus 2. We're now beginning to pressurize the tanks within the Saturn V vehicle. We'll pressurize all of the tanks in all 3 stages with gaseous helium. As the pressurization builds up, it's being monitored here in the control center now at 1 minute and 40 seconds and counting. Our status board still indicating all is well. The status board shows instrument units, spacecraft, and all the launch support operations well at this time at 90 seconds and counting.
We're expecting a decibel count back here at the press site of some 120 decibels. Tremendous roar.
1 minute, 16 seconds and counting. The pressurization continuing within the vehicle at this time. We also have hydraulic commit that will permit the hydraulics to drive the engines in the first stage. Liquid hydrogen tank in the second stage now pressurizing. T-minus 60 seconds and counting. T-minus 60. Our status board still shows we're go at this time. T-minus 50 seconds and counting. We have transferred to internal power. The transfer is satisfactory. The 6.2 million pound Saturn V launch vehicle now on its own power at 38 seconds and counting. To repeat, the ignition sequence will start at 8.9 seconds. We'll be looking to lift off at 0. T-minus 30 seconds and
Don't forget.
We'll count down from starting T-minus 20. T-minus 25. Stage is reporting ready for launch. T-minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9. Ignition sequence start. 5, 4. We have ignition. All engines are running. We have liftoff. We have liftoff at 7 a.m. The tower has...
My God, our building's shaking here. Our building's shaking. Oh, it's terrific. The building's shaking. This big glass window is shaking. We're holding it with our hands. Look at that rocket go into the clouds at 3,000 feet. Roars, terrific. Look at it going. You can see it. You can see it. Part of our roof is coming here. You're seeing that with the so-called Igor camera. Sequence now of the launch.
Climbing very nicely. Our velocity is now 2,000, about 2,500 feet per second. We are 3 miles downrange. 3 miles downrange.
The rocket has just gone through max Q, and that is one of the first critical stages after liftoff, which of course is the most critical stage.
Flight controllers are reporting enthusiastically that all parameters look good.
We're now
The flight director says go all the way.
How about
1
that?
minute, 50 seconds.
How about that? The Saturn has done it again. Right on time, precisely on time, except our clock
15
stopped.
miles downrange. 2 minutes. Coming up on staging.
This is separation of the first
Booster says
stage.
he's go on all sources. The inboard engines have cut off. The inboard engines have shut down at approximately 2 minutes, 18 seconds.
The first engine cuts off.
No reports yet on the outboard engines.
There it is. They're
The
staging.
outboard engines, we can see it visually. Outboard cutoff was called at 2 minutes, 34 seconds.
Beautiful. You see the first stage dropping away.
The S2 has ignited. Thrust is okay on the S2. The booster says we've got a good second stage. We are 64 miles downrange. Velocity approximately 10,000 feet per second. Second plane has separated the interstage surrounding the second stage engines, and the tower has jettisoned.
We saw that. You saw it on that long-range camera.
The tower jettisoned right on time. We're 3 minutes, 20 seconds into the flight.
At this point, the flight is about 50 miles downrange, 100 miles high, and you're seeing it very clearly on that Igor camera, despite some cloud cover. You can see the rocket, the escape rocket, still dropping behind up there.
Flight Dynamics says, in response to the flight director's question, we're real good. That's Flight Dynamics, and the plots here certainly back him up.
This S2 burn, that is the second stage ignition, lasts some 6
downrange
minutes.
distance now is 150 miles, 150 miles downrange. Velocity approaching 11,000 feet per second.
You see on the pad here a fire that was started by
4 minutes into the flight.
by the launch. It doesn't look too serious at the moment, and some of this was expected.
The ground track is reported to be exactly nominal.
One of the things that had to be tested here, of course, was this launch facility, and one of the things that they have to know is how much damage is done to the launch facility, how quickly it can be turned around and prepared for the launch. At this point,
200 miles downrange now, and our altitude is approaching 80 miles.
those 5 J2 engines, 1 million pounds of thrust.
An aircraft off the east coast of Florida has acquired the spacecraft and booster combination.
Yes.
Coming up on 5 minutes. Flight director has just quizzed his booster controller on how the S4B, the third stage of the vehicle, looks, and he's just as happy about its looks as he is the second stage.
Here we see a picture. I'm interrupting Paul Haney to tell you about the picture you see from the top of the umbilical tower. That camera, that slave camera, survived the heat and the blast. How we wouldn't know 3 miles away when we took such a beating. But you see the hoses on the launch pad hosing it down after that heat, which is enough to take off 3/4 of an inch of concrete, they tell us. It burns it away. Fantastic launch. And as we look now into launch control, those 450 launch control operators have now done most of their job. They've been watching on these close television cameras that are right in the launch site and monitoring all of the phases of the flight. And they have every reason to congratulate themselves. So far, the flight has gone exceedingly well. There's still much to be done. The second stage.
Flight, and we are rapidly approaching a point where we will hear an event called propellant mixture ratio shift. And this will cut down the flow of oxidizer and thus enhance the flow of the hydrogen propellant.
The next critical moment we have here in the flight comes about 2 minutes from now, when the third stage must ignite. This third stage has been tested before. So far, the first and second stages, which had not been tested before, have worked perfectly. The third stage has run previously, and no trouble is expected with it. Its big test will come on a second ignition a little later on in the flight. But the next critical moment, about 2 minutes from now, and as you hear Paul Haney reporting, everything is going exceedingly well. Boy, I'll tell you, though, that rocket goes off with quite a blast, and we may have to give some reconsideration to just what we build here at the press site. We need a blockhouse, not a cottage as we have here now for our studio. The roof came in, part of the paneling of the roof, the clock stopped. This big glass behind me here, which I have been worried about, I must say, for a couple of weeks, and been assured by NASA engineers, although they're not responsible for it, and they made sure that they weren't responsible for it, which is the first time I had a little suspicion that Bobby Wessler, our producer, might be putting something over on me. This piece of glass was shaking so that Jeff Grownick, my assistant, and I were holding on to it, hoping that somehow or other that would keep it from coming in on our heads. That blast was something absolutely unbelievable. I was at the first Yucca Flats test of the first open shot of an atomic bomb in this country. That was back, 14, 15 years ago. We have an animation now of the second stage ignition, which has just come up. Well, I was back, we were 5.5 miles from that blast, and it wasn't as great as this blast from 3 miles. At 8:40 into the flight.
20 seconds, there's a possibility that we may have lost one engine on the second stage. That's only a possibility, not a confirmed fact. 8 minutes, 30 seconds.
You just heard Paul Haney say there's a possibility of a loss of an engine. There are 5 engines on the second stage, and a loss of one engine
coming up on staging of the second stage
would probably not be critical. Second stage is dropping away at any point.
Cut off on the second stage.
There it is, the second stage.
8 minutes, 50 seconds in. We have J2 ignition on the third stage. And Booster says the thrust is okay on the third stage. He confirms thrust, a good thrust, 9 minutes into the flight.
The third stage has one J2 engine, similar to the 5 engines on the second stage. It develops some 200 to 225,000 pounds of thrust.
We're 914 miles downrange. Our velocity now up to 23,000 feet per second. The performance right at the end of the second stage seemed to be a little erratic. We had some data dropouts. One flight controller thought perhaps we'd lost one of the 5 engines. We have no confirmation yet. I'm sure it'll turn up in the data. We did burn out approximately on time, and the S4B ignited right off on just as it should have.
This third stage burns about 2 minutes and 24 seconds, something like that.
Report that the first stage of this vehicle has impacted about 100 or more miles downrange. We have ships deployed in that area which will attempt to recover as much as they can of that first stage, and we will try to get some camera packages which were mounted on the skirt of the second stage. 10 minutes and 18 seconds into the flight, and the flight director advises we have about 1 more minute of burn ahead of us. The Vanguard ship has acquired out in mid-Atlantic. We are 1,200 miles downrange right now, and we're coming up on 25,000 feet per second. No matter what happened to this point, we could burn our service module engine and get orbit capability. 10 minutes, 55 seconds into the flight.
So now we do know that we will get an orbit. We've reached just 17,000 miles an hour.
Of the S4B, a first report.
The animation shows the...
11 minutes, 10 seconds. We have a confirmation of cutoff from the Vanguard ship in mid-Atlantic. The S4B has shut down. The report confirmation came in here at 11 minutes, 10 seconds. The ullage engines on the S4B have also fired. And the word from the ship in the mid-Atlantic is we're all go. We're all go.
Every sequence has come exactly on time. That shutdown was scheduled for 11 minutes and 5 seconds into the flight. They got a confirmation at 11 minutes and 10 seconds into the flight. And now, at this point, they are inserted into orbit, 116 miles high. And most of the test has been conducted and is successful. They have gotten the first and second stages to fire as planned. The orbit has been achieved as planned. Now, with this orbit, they will circle the Earth twice, and then 3 hours into the flight, they will change the orbit over the southeastern United States. Near the end of the second orbit, they will pitch up the spacecraft, fire the third stage engines again, and fire the spacecraft out into space a little bit further. They'll change that orbit up to 10,808 miles. That is called an elliptical orbit. The perigee would still remain back at the 115-mile height. This is an Earth-intersecting orbit. In other words, if the spacecraft turned around at that 11,000-mile distance out and came back, it would impact the Earth. It would hit the Earth. However, it's not going to do that. Because they're going to fire the spacecraft's own service propulsion system and bring it back slowly as it's intended to be brought back. That is at 25,000 miles an hour, if you can call that slow. But bring it back precisely to a 40-mile keyhole in the sky over the Pacific. Let's take a look again. If they promise us that we won't take that buffeting back here at the Space Center on a relook, let's take a look at the launch of Apollo 4. A magnificent sight that occurred some 13 and a half minutes ago. There's a little breakup on our tape because of that tremendous vibration from the rocket. And here it is.
Ignition sequence start.
The ignition came
5,
on
4.
time.
We have
Everything
ignition. All engines are running. We have liftoff. We have liftoff at 7 a.m.
A building shaking here. A building shaking. that rocket go into the clouds at 3,000 feet. Roars, terrific. Look at it going. You can see it. You can see it.
This is a videotape.
Part of our roof has come in here.
Videotape replay of the rocket
Seeing that
launch.
with the so-called Igor camera. Sequence now of the launch.
Climbing very nicely. Our velocity is now 2,000, about 2,500 feet per second. We are 3 miles downrange. 3 miles downrange.
The rocket has just gone through max Q, and that is one of the... Well, that was a replay by videotape of the launch 15 minutes ago of Saturn V, the most powerful rocket man has ever built, as far as we know. The big proton rockets of the Russians, they do not equal the 7.5 million pounds thrust of the Saturn V. And as you saw, the fireball from the rocket, as that Igor camera picked it up almost 50 miles downrange, was so immense that it actually flowed back from the rocket. We had never seen that view before. Previously, rocket power is such that there's just a small burst of flame from the tail. This was a great fireball of flame. They say that the launch of that rocket was visible in Jacksonville, Florida, some 180 miles from here. I can believe it. It certainly was a bright spot here. It was almost blinding to the naked eye as we put glasses. The flight is going exceedingly well. All 3 stages have done their work. The spacecraft is in orbit, unmanned, as you know. We'll make 2 orbits before being fired now, the next critical point, some 11,000 miles out into space. It will be returned 8 3/4 hours from launch. It is hoped that in the re-entry test it will hit the 40-mile spot in the sky into which it must come. If it comes in too shallow, it would skip on out from the atmosphere, hitting the atmosphere like a stone skipped into a lake, and skip on out into space, never to return. If it comes in too steeply, it hits the atmosphere too quickly and is crushed like an eggshell. CBS News color coverage of the flight of Apollo 4 will continue after this message.
All right, after the introduction of that rocket that you saw this morning, I think maybe all introductions are superfluous, but obviously they're not. Some things need to be said, and the first speaker in Houston this afternoon will be Dr. Robert Siemens, the Deputy Administrator of NASA. Dr. Siemens.
Well, what we've all seen and heard today has been the result of a hard-driving, disciplined effort that's been carried out for an extended period of time. The engine development was initiated in 59 and 60 as the engine that powered the first stage of the Saturn V, the F1 engine, was started first, and the J2 engine was started a short time later, both in President Eisenhower's administration. Then in 1961, after a careful review of this country's position in space, including a careful look at the Soviet program, President Kennedy, on recommendation from then Vice President Johnson, recommended a major acceleration in our space activity. This led rather immediately to approval by the Congress and the initiation of programs to develop a major new launch vehicle capability and to initiate development of an advanced manned spacecraft that would have the capability to maneuver, rendezvous, dock, and carry out missions out to and including landing on the moon and return. At the press conference yesterday, we stated that today we'd be flight testing the Saturn V, that is this new launch vehicle, for the first time. We said that we'd be flight testing the Apollo reentry at lunar return speeds for the first time. We said that we would be live testing our launch and operational facilities for the first time. And it would be testing a development and operational team in its first major mission for the first time. These goals, as you know, have all been accomplished. Today, we placed in near-Earth orbit over 280,000 pounds. To give this some perspective, this is 3 times the weight of the 6 manned Mercury capsules and the 9 Gemini capsules that have been flown by our astronauts. In response to questions yesterday, we said that we would not be completely satisfied with Apollo 4, that is today's mission, unless we went through the planned mission all the way to spacecraft recovery. I say the mission is successful because the Bennington is now alongside the capsule, and we can be sure that it will be aboard in 30 or 40 minutes. We know that we have obtained a great deal of important data. Just the conduct of the mission itself gives us very valuable information. We have the spacecraft to inspect. We have all of our telemetered information and photographic data obtained on the ground. We've recovered 2 cassettes that were taking movies from the S2 stage, so that we will have a great deal of information to analyze and to evaluate. And we know that this is extremely important for the upcoming succession of flights that will lead to and certainly include the lunar landing. But I believe that more important even than this is the clear indication that our team of government, industry, and university people was not found wanting, and that we do have the capacity in this country to be preeminent, not only in space, but in all human endeavor involving science and technology. The power of the Saturn V is exceeded many-fold by our power in this country to accomplish the near impossible for the good of all mankind. Thank you.
Dr. Miller?
I'd like to say just a few words of my pleasure, my pride, and my happiness for the results of the work of the 300,000 people who at one time or another have contributed to the Apollo program and to the success that we have enjoyed today. A friend of mine, Bob Holtz, whom many of you know, has accused me of failing in times past to convey any idea of the magnitude of the task that was exemplified by the flight that we pulled off today. Bob's analogy of the Apollo program is one that says it's the combination of 3 of the greatest projects that man has ever undertaken in the past. A combination of the building of the pyramids, the creation of our nuclear weapon systems, and the development of the supersonic transport, all rolled into one. Now that may be a bit of a superlative, but to give you some idea of the magnitude of just one aspect of today's flight, you know, there were over 125 computers which were programmed to talk to one another in order to carry out the communications that were used to identify and understand what was happening to the launch vehicle and the spacecraft as it traveled around the world. And that represents one of the largest programming jobs ever undertaken in this nation. I was groping for some measure of the magnitude of the particular flight today and I may be getting carried away, but in a very real sense, the complexity of this flight is equivalent to taking the first nuclear submarine, instrumenting it so that it could be driven out by itself across the ocean to a target point and then returned, and checking it out on the ways at the factory, and then launching it and letting it go forth and return, all without human intervention, or at least without anything other than sending commands to it. I do think that this was a tremendous achievement, and I again say I'm proud of all of the people that have been involved in the program. Thank you.
There's, well, I don't believe all the participants have gathered yet at the Cape. There's a gentleman down there who himself has had a lot to do with the development of this rocket, and who heads a very able team that had everything to do with the building of the launch vehicle. I'm sure everybody would like to hear from you, Dr. Von Braun. This is called queuing in the blind. We'd like to wait. All right, if we can come back to Houston. I'm sorry, Bill Schneider?
I can't add much to what was said there. As a matter of fact, I don't think I can add anything. I would like to say one thing that I've been wanting to say for the past 5 years. In all sincerity, I'd like to thank the American people for their faith in our space program, which has given me the opportunity to work with the people I've been working with. Thank you.
General Houston?
Well, I'd first like to congratulate the NASA government team for this very significant, very tremendous success today. I can say that, and speak for the DoD, that we certainly are happy to be a part of it. And in respect to today's mission, we were operating with a new team in a lot of respects. I'd like to mention Admiral Christopher's name, who was the commander of the task group in the Atlantic, Admiral Lynch's name, who was the commander of the task group in the Pacific, and it was very gratifying to work with them and see their status of preparations and responsiveness to the possible problems, which fortunately we didn't have to carry out. But there were a few significant things in today's mission which portend things for the future. Today in the network we had the first Apollo ship, for the first time, the Vanguard. There will be 5 of these eventually. It performed its job in very worthwhile fashion, and we're quite proud of that. We also had the 5 Apollo aircraft up, 5 of the 8 that we will have eventually. And in all respects, they performed their job. On launch, one of our jobs was to attempt to photograph, observe, and recover the S-1C stage. We did observe it. We did photograph it, I understand. But of course, it broke up, and we recovered some of the debris. Another job was to recover the photo cassettes, which we did recover intact. And as far as I know, they are back at the Cape right now. The rest of the mission was complicated in regards to the recovery, in that we had a large number of contingency abort plans that we were ready to carry out, which gave us some very significant training and preparation for the future. The only thing significant we had to worry about particularly was the weather in the primary recovery area and west 900 miles where the destroyer, the Carpenter, was. In this case, we had a front along the path, which we looked at very closely last night and this morning, and decided to continue the aiming point after discussions with Mr. Kraft and Mr. Snyder here. Fortunately, I came right down within 5.9 miles of the carrier. That's the figure I heard, and it was a good decision, I believe. So again, it was a It was a very significant mission, very well done. We're happy to be part of it, and we look forward to greater things in the future.
Thank you, General. Our next speaker is Mr. Christopher Columbus Kraft, with a K, our Director of Flight Operations.
Thank you, Paul. I'm very pleased to say that I'm very proud of the team that we had in the control center today, run by Mr. Lunny. Very proud of those boys. I think they did a wonderful job. The people at the Goddard Space Flight Center are not represented here, but I think we ought to point out that today was a big day for them in bringing up the new Apollo network. It was quite a job to get that system ready for this flight. I think they did a tremendous job and certainly ought to be congratulated. I think the whole Apollo team and the Apollo hardware matured today, and I'm proud to see our boys a part of it. Mr. Lunny.
Well, Chris has mentioned all the elements of the team that we work with, and I also was delighted with the way that the team acted and conducted themselves throughout the test today and the planning and the pre-launch operations that we've been engaged in for the last several months. Speaking for, I'm sure, all the members of the team in the control center and all the people around the world, I think all we have to say, it was a great thrill to be a part of this operation, and it's wonderful to see the mission itself be so successful.
And speaking as an old man of 30 years old, that's quite a statement, Mr. Lunny. I understand Dr. Von Braun may want to reserve his comments till the other center directors are there later. Have they arrived yet? Well, if not, then we'll proceed with questions in Houston, if there are any.
In a sense to morale in my opening remarks. The team was not found wanting today, and I'm sure that having carried out such a successful mission, that this will give the team confidence for future missions, and it will give those who must provide the resources, the country at large, the Congress, I'm certain, confidence that they are providing resources for a team that is going to make maximum use of the facilities and of the people involved to achieve maximum benefit, not only for the lunar landing, and important as that is, but for a variety of short and long-term benefits.
How close did you come in your trajectories and burns to your nominals? Do you have any figures you can use at all?
I didn't bring all the papers over, but as far as we could tell, everything was just about on the money. We inserted into an orbit which was probably within 2 miles of what we were shooting for. The second burn was the second Saturn IV S4B burn, was very, very close to what we aimed for. We followed that up with a 16-second burn with the service propulsion system. The planned burn was 15 seconds, as you know. We were very, very close to our desired cutoff conditions. The second service propulsion burn, the last one of the day, I think the accuracy of it can be attested by the landing point, which was about 18,000 yards from the carrier. So we couldn't have been happier with the accuracy of the systems and the way the vehicles performed during the major maneuvers.
Are there questions at the Cape?
Party arriving. We hope that the whole group will be here shortly. Right here in the front row.
Somebody's volume is down. Let's try it again.
Would you repeat the question, sir? Was the re-entry sequence and the landing nominal in all?
I think the question is about the re-entry sequence. Is that right?
Let me see if I can pass on the question here. Apparently not receiving it.
Cape, we're not hearing you at all. Give me that. Yeah, Jack, give me the question. Just give me the question on the phone. I'll repeat it.
It's an opportunity.
Okay. The question is, was the reentry sequence normal?
In a word, yes. We played the tapes back from Guam, the station at Guam, and we were able to verify the last function that we were not able to verify in real time. That is, the separation was normal. From there on in, we had contact with the Uriah aircraft. That is, the Uriah aircraft had contact with the spacecraft at about the time we expected them to, as we went through the two blackouts. And the reports were about on time, near as we could tell. And then the final proof of the pudding, of course, was the visual contact with the spacecraft on chutes off the bridge of the Bennington.
But you're satisfied that somebody did see the events going into blackout and coming out?
We saw the events through separation. The next event that we really have a very good hack on is the landing time, which seemed to me to be within about 15 seconds of what we predicted before we went into the sequence. So I can only judge at this time that it was as normal as we could get.
Okay, did you copy that, Jack?
Right. Art Snyder, Chicago Daily News for Mr. Lunny. Did the black boxes do the job that a man could have done in this mission? Or was there any point at which you would have liked to have seen a man in the loop?
Well, I guess I would have liked to have seen the man in the loop the whole way, and the sooner we can move into that, the happier we'll be in the program, and the more safely and more successfully I think we'll be able to operate the missions. However, as the equipment was designed for the flight, as near as we could tell, it worked essentially flawlessly throughout the flight. As you know, this was a long flight to fly unmanned. We had to retain a lot of accuracy in our systems. We also had to go through several fairly complex maneuvers, both with the launch vehicle and the spacecraft. All of those maneuvers were performed very successfully, and I guess today I'm very happy with the electronic pilot we had.
Dick Lewis, Chicago Sun-Times. Also to Glenn Lunny, would you, perhaps you expressed yourself on this earlier and I didn't catch it, but would you have preferred, would you have felt easier if there had been a crew in the cockpit today?
Well, I have to qualify that answer because, as you know, this was the first time we were flying the Saturn V launch vehicle, and our attitude has been that we would want to fly at least two of those vehicles in order to assure ourselves that the launch vehicle has been properly man-rated. So in that regard, first time out, we're going to fly them unmanned. But when we move on, we'll be very glad to see the pilots back in the loop.
Julie Devine, Metalworking News. Mr. Lunny, what was the highest heat experienced by the heat shield, and can you comment on any performance parameters about the heat shield?
The best, I don't have the numbers in front of me. The best I have is that the conditions that we arrived at today were a little bit higher than we had planned for by just a few percentage points in both the total heat and the total heating rate. However, this may not end up being true when we actually get the spacecraft back, establish what the lift-to-drag ratio of the configuration was, and see what the reentry trajectory was that we actually flew. So preliminary indications are that we flew it a little bit hotter than we had planned by perhaps a percentage point, but I think all the numbers are not in on that.
Put a number on that. Our nominal mission would have given us a heating rate of 594 BTU per square foot per second. As Lonnie pointed out, based on trajectory data, we may have hit a little higher than that, which would have been a more severe test of the heat shield, but we won't know this until we analyze the data. On a nominal return from the moon, our heating rate will be about 2/3 of that number. So it has been a severe test of the heat shield.
I'd just like to apologize. I have to leave. I have to go out to the West Coast to start the next spacecraft a little bit further on its journey here. Apollo.
Okay. For excusing Dr. Miller. I'm sorry. Go ahead, Jack.
Get the line back up there.
Ed DeLong, United Press. Chris, do you have any figures yet on the heats encountered inside the command module?
No, we actually have no telemetry data that we've had a chance to look at that would indicate what the temperature inside the command module was.
Did you have any problems with telemetry or communications? There was some indication there might have been a telemetry problem earlier today.
We had what we think were telemetry problems a couple of times. However, as you may know, we were flying two new systems. On the launch vehicle in orbit, we were flying the S-band system, which we will use for the lunar vehicle. We were also flying the S-band frequency system, which we have on the spacecraft, the unified S-band system, which carries all of the spacecraft data. We occasionally had what we assumed to be at this time antenna pattern problems, which just mean that the attitude of the vehicle was such that the antennas on the vehicle and the ground antennas weren't properly aligned. However, we kind of expected that we would have some of those kind of problems during the course of the day, and I think when we get a chance to look at all the data, we'll have a better handle on what to expect next time and what we can do to improve what happened here today.
Now the other Senate directors have joined the conference at the Cape, and we want to switch down there for a statement from Dr. Von Braun.
All I can say is that I'm highly gratified about the results of this test. It was really a textbook launching all the way through from launching exactly on time to performance of every single stage, particularly the restart in orbit, which was something experimental, went off quite successfully. As Dr. Siemens pointed out yesterday, we wouldn't consider this launch a complete success unless we had the spacecraft safely recovered on the deck of the carrier. Now looks like this is just only a few minutes away. I'm very happy and somewhat tired, but I think we have achieved three main goals the last years and months and days and hours. One is a new concept of a facility has been brought in, has been constructed and exercised and proved to operate well. Past post-launch inspection indicates that we have only minor refurbishment to do. We're very satisfied with that. Second, we had a very almost monumental task in getting together a group of people. Some are quite new in this business. We had to build up a team that would work together as if it was composed of people who had done it many, many times. To this, our countdown demonstration work has helped us immensely. In this context, I believe I can say that it's one of the most complicated, interlaced, complex launch countdowns that are in existence. And the third one, of course, is the exercising of the hardware proper that is contributory to the launch vehicle and spacecraft. And I believe this also has worked well. So I'm very happy and proud to be permitted to be part of this team, and I think that demonstration has been made that not only has been brought online a new launch vehicle of tremendous power, but also a capability that will help this nation to maintain its position in space. I'm too very proud and happy on this day. I think the entire group of people that have worked all these systems have reason to be proud and happy too. I think both the spacecraft and the launch vehicle performed very well indeed. I believe it's perhaps easier for many of us to understand the launch vehicle performance. We can watch it, at least a good part of it. It's tremendous, and I certainly was as impressed as any. I think in some ways the spacecraft probed just as deeply into the unknown today as the launch vehicle did into the technology of large rockets. First, of course, this is the first time that a full-scale vehicle has really re-entered the Earth's atmosphere at this speed. And of course, we won't know till we see the data and have a look at the ablation material how well it did. But it was at least well enough to come back intact. We know that. There are other things that will be of interest. We had radiation monitoring aboard this craft as it went on up through to the apogee of over 10,000 miles that will show what the radiation levels are inside the cabin. At least we hope they will if all of the instruments work. There was also on board a camera which will show an astronaut view of the Earth from a color camera, which we hope works. And I think that other things that aren't so obvious right now, but which will be very, very important to us, things like the knowledge of the loads imposed on the vehicles, the vibration levels, all these things we can now put in the realm of measurement much more completely than and much more satisfactory than having in the realm of estimates and calculation. All in all, I think that it's been a very good step forward, and I'm very happy and proud, as Kurt is and Werner is and all the rest of us, to be part of this team.
In addition, here at the Cape to the three center directors. We have General Samuel Phillips, who is Apollo Program Manager, Mr. George Lowe, who is Apollo Program Manager for the Manned Spacecraft Center, Houston, Rocco Petrone, who is Launch Director for the Apollo 4 mission from the Kennedy Space Center, and Dr. Arthur Rudolph, who is Saturn V Program Manager from the Marshall Space Flight Center. We understand that Dr. Siemens has some additional remarks at this time.
I'd just like to amplify the response I gave to the question here regarding morale. The morale of those involved in the Apollo program following the accident that we had last January was low, in the sense that everyone involved felt that there must have been something that he or she could have done to have avoided the accident. We have to recognize when we have accidents that they are not acts of God, they are human mistakes, and in that particular case, after a very careful review, we uncovered a large number of areas where we felt that we should and could make improvement. In the sense that people were dedicated to move ahead and do a better job, morale has always been high. And the group of people involved have moved ahead, I think, in a remarkable fashion following that accident. At times it has not been easy because of outside pressures and outside concerns about the capability of the team. I'm sure the team itself has wondered whether they really were up to the job and up to the responsibility. I believe that the results achieved today clearly demonstrate that this team of people, made up of NASA people and DOD, other government people, many industrial people, and university research people, truly have the competence to not only take on the manned lunar landing program, but any other space objective that this country feels is important and to which we should dedicate our efforts.
Thank you, Dr. Siemens. I know there are a great many newsmen at the Cape, something on the order of 300, so let's go back down there and pick up their questions.
Right here in the third row.
Vic McElhenney, Boston Globe. Can I ask about the guidance system and how accurately it performed on splashdown?
Best number we have for the splashdown accuracy is 18,000 yards from the bridge of the Bennington. I expect that number will be improved somewhat as we look further at the data, but that's a pretty good estimate of what it is.
Right here in the second row. Dr. Divas, was there any measurement on the noise level, decibels at launch?
Yes, we had equipped the total launch pad with quite extensive measurements on vibration level, noise level, seismic problems, etc. We have not, temperatures of course, we have not evaluated those as yet. Walker, do you know of any measurements that we made in real time perhaps?
No, I do not. They'll be values available shortly. Today it's not available yet.
Right up here.
Peter Fairley, London Evening Standard. Can somebody tell me how the apparent disintegration of parts of the booster rocket bodes for the future of recoverable booster sections?
We have studied recoverable booster systems for a long time, and if we had a contract, we would know how to build one today. The problem is that the development of a recoverable booster system is a major investment, and you have to amortize this investment against a sizable number of launches before you ever have a chance of getting your money back. As long as we are talking only about 15 Saturn Vs, we are on the wrong side of the power curve. We'll never be able to get our money back. If you wanted to order 500 of them, we'd know how to do it.
Harry?
Harry Pease, Milwaukee Journal. I'd like to rephrase a question that was asked earlier and ask if any of you gentlemen, either here or in Houston, know of anything that happened today that would have endangered a crew on board. We understand that it's unthinkable on the first flight of a vehicle, but did anything occur which would have endangered a crew?
Speaking for the spacecraft, I certainly don't know of anything today that would have endangered the crew. But I think we have to stand behind the answer that Lynn Lundy gave earlier, namely that we want to fly this flight and another one before we would consider putting a man on the new launch vehicle.
I would like to add something to this answer. There's some indication, but let me emphasize that this would not have endangered the crew. But we have an indication that there was one irregularity, in all likelihood, in the so-called propulsive venting system of the S4B stage, which is the Saturn V's third stage. In order to keep the liquid hydrogen oriented on the backside of the tank, we vent the hydrogen out in such a way that it exerts a few pounds of thrust as it squirts out of the vent valve to keep a very, very slight acceleration on the vehicle, just to keep the liquid hydrogen settled at the bottom. If you didn't do this, you could lose substantial amounts of liquid hydrogen through the vent valve and go into your second burn with a half-empty tank. For this reason, we have this propulsive vent feature. We have an indication that the vent valve admitting hydrogen to this propulsive vent did not close when we started to repressurize the S4B stage for the second burn. However, there is enough gas available to override this relatively small amount of leakage that goes out through the vent. This, however, required an intelligent decision on the part of the man controlling this operation on the ground. They knew that the valve hadn't closed, and had he started to pressurize the tank, say, 5 minutes or 10 minutes before starting up the engine, he would have lost so much pressurizing helium through this open valve that he could never have built up enough tank pressure. So he waited prudently until about a minute before the restart was due, and then pressurized at a pretty rapid rate, and this brought the engine close enough into the start box for the J2 engine to restart up. And the moment the engine starts running, it produces enough evaporated hydrogen to build the tank pressure up even to the normal level. It looks like this was a kind of a marginal situation. There would have been a chance that had it not worked out so well and had it not been done so intelligently, that we may not have been able to restart the J2 engine after two orbits. What I said here requires re-verification as we look at the data, but this is the best information available at this moment.
Right here.
Dr. von Braun, this question was asked earlier this morning, but I would like to know your explanation of what we're going to do on 502 besides flying the complete unified hatch. In short, what are you doing new? Are you just going to retest everything just as you've done today? What is the real purpose besides the hatch for the next flight, and when would you predict it? And also, we would all like to hear your real comments at the moment of liftoff. Just what did you say?
My feeling at liftoff was, go, baby, go. All I can tell you, this is a very, very long vehicle, and it takes 10 seconds to clear the tower. These were by far the longest 10 seconds I've ever lived through. I watched it through binoculars. As far as the purpose of Launch 502 is concerned, I thought we ought to distinguish between the necessity of repeating a launch vehicle test and certain changes in the flight profile for the spacecraft as it re-enters. As far as the launch vehicle is concerned, I think you can put it down in very simple terms. 2 successes in a row make you a lot more confident than one. And you have to draw a line somewhere how many flights you would like to have under the belt before you put a man on these things. And we decided that 2 or maybe 3 may be a good number. Now, as far as the spacecraft is concerned, I would suggest I pass the question on to Mr. Lowe.
Well, spacecraft 20 for the next flight, which incidentally was formally accepted at North American yesterday, is essentially identical to spacecraft 17, which was on this flight. The only difference is that whereas the new outward opening hatch was only mocked up on spacecraft 17, the actual hatch will fly on 20. I think I should say, though, that we may have gotten enough data on the hatch just from the mocked up hatch to qualify that system for manned flight at lunar entry speeds as well without the spacecraft 20 flight. But the only difference in the spacecraft is the hatch.
Right back out of the second one.
What was the re-entry velocity?
The best I can tell you at this time, it was just a little bit greater than the 36,333 feet per second that we had planned for. Perhaps another 100 or 200 feet per second is all I can estimate here.
Back up here? Way back up, Jeff.
Dave Zinman from Newsday. Can you tell me when the next Apollo flight will go and what the major event will be?
The next Apollo flight will be Apollo 5. That's the LEM-1 unmanned on the launch vehicle 204. The launch vehicle's on the pad. The lunar module is in the spacecraft checkout building. The schedule will call for the LEM to be installed on the launch vehicle the latter part of this month. We expect to fly it shortly after the first of the year.
Back up here.
Dick Hope from the Springfield Museum of Science and Springfield Union. Perhaps this has been asked before, but what is the major thing to which you attribute the spectacular success of the intensely complex mission? And how would you compare the testing of this system with the testing of, let's say, the Atlas 6 or 7 years ago, and how far we've come down the road and what this means for manned flight per se?
I guess I'm the only one here except for George Lowe that was involved in the Mercury Atlas, if you're talking about the Mercury Atlas. And it is true that this system here today is, if you measure it in terms of energy, is 20 or 30 times greater energy than was involved in the Mercury Atlas. And I think the work and the complexity and so on tends to go in the same ratio as the energy. So it was, I think, a tremendous achievement of organizing something as complex as this. As you can remember, we could just about barely get a Mercury Atlas off because it was so complex in its day.
And one of the first things that I thought of when we were given the task of a manned lunar landing was, gee, we're going to have to get a whole lot better technology in order to be able to handle systems that are the order 20 to 30 times as complex. And I think the performance here today shows that it is possible to do it. And although it isn't easy, and I think that we all will benefit by a lot more practice in missions of this type. And maybe Sam would like to, General Phillips would like to add something to this, but it has been a big problem, and it will, and things this complex will continue to be a problem to get off.
I don't think I could really add anything to it. I think the demonstration of Apollo 4 today was a tremendous technological achievement and represents the pulling together of a vast range of technologies and a wide range of industry. I think it was a tremendous technological achievement, and it's hard to put a number on it, but I should say it was many times greater in its accomplishments than missions of 6 or 7 years ago.
Let me just add an interesting number that I tried to figure out here, and I hope it's correct. I think we put 285,000 pounds in orbit today. And the Atlas that lifted John Glenn into orbit, the launch vehicle, all of its propellants, and the spacecraft, fully loaded before liftoff, weighed about the same amount. So, in effect, what we did today could have put the launch vehicle and the spacecraft and the propellant into orbit that we, a few short years ago, had on the pad to just launch a spacecraft.
I would like to add something to responses to your question, how come that these very complex missions are tackled with apparently a much higher degree of confidence and surely with a higher degree of success in Atlas. I think it has a great deal to do with the method, with the methods that we are using. And I personally contribute, as far as the launch vehicle is concerned, the greatest reason in this field to our automatic checkout procedures. We computer check all critical elements of our launch vehicle all the way up to liftoff. This provides us with an unheard of degree of knowledge of the state of the various subsystems, whether things, for example, like the control loop in the first or the second stage are really operating well before takeoff. So we have a much greater assurance that we won't launch a rocket with anything sick in the system before it even takes off. Now, this degree of visibility we never had in the past, but one should realize that one pays a price for this. In the first place, of course, you're dealing with computers which in themselves can introduce errors and delays. And secondly, the more you know about your vehicle, the greater is the likelihood that you do discover something that is not operative, and as a result you cannot launch. So it is like a man seeing his doctor every 2 weeks. Chances are that the doctor, by continuously running checks on him, will update his evaluation. The evaluation of his diagnosis a lot better than a man who very rarely sees his doctor. So we have much more assurance that we won't launch a sick bird, but at the same time the probability of hitting a red line while we are in the count is vastly increased. And for this reason, I think the fact that we were able to launch this thing on time is probably the greatest accomplishment of them all, because it shows that in spite of all that knowledge we had about the bird, we had no red line values.
Hey, Joe.
Phillips and his crystal ball department, at which he excels. If 502 Sam is another picture book mission, or storybook mission, as much as this one seemed to be, and the first unmanned lunar module tests come along well, would we advance the lunar landing program by flying the first manned Apollo flight atop of Saturn V, and would you so consider doing?
You're persistent. Your ifs, I won't restate. I have every reason to believe that Apollo 4 will be another storybook mission, and that Apollo 5 will also. We've organized our schedule in such a way that we're prepared to fly additional unmanned flights, specifically an additional unmanned LEM and an additional unmanned Saturn V. We have also organized our plans and our preparations in such a way that we can capitalize on real success and be able to move the program forward to the limit of the what we will judge to be reasonable in moving it forward on the basis of all the events in hand. We are organized to move forward more rapidly in the event the total situation warrants.
We understand we have some up-to-date information on the recovery efforts with the Apollo spacecraft. We're going to switch back to Houston at this time.
Yeah, Jack, the seas out there, those 8-foot swells, are making recovery one of the most difficult parts of the mission. The carrier tried once and is having to go around again and slip up on it on the good side. But the seas are rough, and we do not have an estimate right now, but they are working the problem. I know the people at the Cape are at least 8 hours more tired than we are here in Houston, so we're going to adjourn at this point. Thank you very much.